Alright guys, welcome back. Today we're going to talk about functions and shifting rules, which is section 1.6. So while I'm thinking about it, I just need you to know next week when you're watching the videos, it says section 1.7 on the notes where I write up here, it says section 1.6. So I kind of messed myself up with my numbering, but I quite honestly wasn't going to record the videos again. So sorry about that, and I'll remind you in class as well. Alright, so today we're going to talk about some basic functions and their shifting rules. Nice review of Algebra 2, so let's go ahead and talk about it. First thing, constant function never changes, remains constant the entire time. It gives you the domain, the range, so this you can look at whether it's an even or an odd function. Alright, a linear function, an absolute value function. Now these are called parent functions, so this is what the basic function looks like. That's what f of y is equal to x looks like. A standard quadratic, it's just x squared, gives you a parabola. The square root gives you this little half a parabola. A cubed gives you this, and a cubed root gives you that. Okay? Alrighty, so we're going to take our notes starting at the bottom of this page. Alrighty? We're going to go ahead and talk about, start off with a nice easy shift. So the first one I want to talk to you about is a vertical shift. And we started playing around with these, that homework, the first thing I gave you where I said graph them on the same thing and then I asked you how they moved. Okay, a vertical shift is going to be where y is equal to f of x plus or minus c. Okay? So I'm going to give you an example. Y equals x squared plus 1. So what do you think it means when you add 1 to the parent function? It's going to move it up 1. If it had been x squared minus 1, it would have moved it down 1. Okay? That's called a vertical shift. Now, let me show you what a horizontal shift looks like, and see if you can come up with an idea. Alright, it's y is equal to f of x plus or minus c. Okay, in real, like normal looking things, it would be x plus 1 quantity squared. So what's different? How are you going to be able to tell what's a vertical and what's a horizontal? It's about, here your function is x squared, and the 1 is tagging along. Here you have to add 1 before you square the function. Okay? I'm going to put a star out here because this guy's going to cause all sorts of problems because I think he should go right 1. Unfortunately, he's a problem child. You really go left 1. So he is backwards from what you think it should do. Okay? Alright, let's talk about reflections. So we can either reflect over the x-axis or we can reflect over the y-axis. Okay? Reflecting over the x-axis is y is equal to negative f of x. So let's take our parent function x squared again. A reflection over the x-axis would look like this. Okay? To reflect it over the x-axis, I'm just going to give you a visual picture. This is my parent function. When the negative is in front, it flips over the x-axis like that. Okay? Now, a reflection over the y-axis is when you have y is equal to f of negative x. Okay, so thinking back to our parent function, this time the negative is going to be contained in the function rule. Alrighty? So again, go back to your picture. I'm going to kind of push it off here to the side. Okay? If this were my parabola, then I would reflect over the y-axis. Okay? Alright, let's keep moving on. Now the next two I want to talk to you about are vertical stretches and shrinks and horizontal stretches and shrinks. And these are going to get a little bit more challenging, and you didn't do a whole lot with these in Algebra 2. So first we're going to talk about a vertical stretch or shrink. Okay? Stretch is when the constant is greater than 1. A shrink is going to be when the constant is between 0 and 1. Makes sense, right? If I'm stretching something, I'm probably, think back to geometry with your dilations. A dilation greater than 1 means you made the figure bigger. A shrink was when you made the figure smaller. It was when it was less than 1. Okay? So what this is going to look like is y is equal to the constant times the function. So again, think back to our parent function for a minute. Y is equal to 3x squared. Okay? Now, this guy's going to mean exactly what you think he means. You're going to multiply by 3, right? Except the only thing we're doing is vertical stretching. So you're going to multiply the y coordinate by 3. So multiply the y coordinate by 3. Okay? The x coordinate, nothing gets done to him. He stays exactly the same. And what we may do is we may practice these in the video, and then I think I might save the vertical strength, stretching and shrink till class. But we'll see. I might give you one in the video. Alright, last thing is the horizontal. Shrink, stretch, or shrink. S-T-R-E-T-C-H, seems that I'm having issues. Alrighty. I am automatically putting a star by him because he's horizontal, which means it's going to be backwards from what you think. Stretching this time is when C is between 0 and 1, and shrinking is when C is greater than 1. Okay? What this is going to look like is y is equal to f of Cx. So it's going to look like y is equal to 3x quantity squared. Okay, so where I told you this is going to be an issue is instead of multiplying, which is nature of what we want to do if we're stretching or shrinking, you're going to divide the x coordinate by 3. Okay? Alright, so my basic rule of thumb is when I see that the constant is inside of the function, I know that it's opposite what I think I should do. Okay? When it is tagging along, when the constant is tagging along, I know that it's going to do exactly what I want to do, and it's a vertical movement. Alright, so hopefully you got some graph paper handy. So go ahead and grab that. I'm going to grab mine. And I want you to describe the shift, graph the parent function, and then graph the shifted function. Alright? Example 1. Describe the shift. Graph the parent function. And then the shifted function. Okay, so let me that's supposed to be a square, not a cube. Okay, so let me begin by saying, just like you did on the first day or second day of class, you can plug these into your calculator. Just realize that I don't have to be super nice and always give you ones that could work in your calculator. So it is important that you know what the rules do, because sometimes I can give you some wacky functions. Alright, so you'll see what those look like. But let's start off nice and easy. So in this case, the constant is tagging along. So he does exactly what I think he should do, and it's a vertical movement. So it's going to go down 3. Alright, so I'm going to sketch my graph. I know that the parent function, if I look at it, has a point here at -1, 1, 0, 0, and 1, 1. -1, 1, 0, 1, 1. That's your parent function. Now you told me that I want to go down 3. So I take every point and I move them 1, 2, down 3. 1, 2, down 3. 1, 2, down 3. And that's it. Okay? Easy schmeezy. Let's try another one. Let's say function g of x is equal to the square root of x plus 1. Alright, so where is the constant? This constant plus 1 is it's contained by the function. So it is a horizontal movement, and it is opposite what I think it should be. So instead of going to the right one, I really go to the left one. Alright, so let's graph our parent. So our parent function is 0, 0, and then he's got 1, 1. And then he kind of curves. It's like a half parabola. There we go. Alright, I'm going to take my points and I'm moving them to the left 1. And there's my shift. Okay, so far so good? Alright, let's try a combination. And I'm going to go ahead and, I think, squeeze it down here at the bottom. Alright, so let's say I have h of x is equal to x minus 5 cubed plus 2. So this time, if you look, I've got actually two constants. I have -5 and I have +2. So first let's deal with the guy who's outside. What's that tell me it's going to happen? I'm hoping you said that we're going to move it up 2. And now inside the function, the cubed function, I have to go to the, you think it should be left, but it's backwards. It should be right 5. And I want you to jot your rules off to your side as you're doing your classwork tomorrow. Alright, so let's graph our parent function. I need a cubed function, which is this guy. Alright, so let's pick out his obvious points. -1, -1, 0, 0, 1, 1. And then you kind of draw that little critter. Alright, each point we are now going to go, and I'm sorry I did my parent function in pink that time. We're going to take each point, move him up 2, right 5. Okay, up 2, right 2, 3, 4, 5. Up 2, right 2, 3, 4, 5. And there it is. Okay? Alright. Let's try this one. Let's do an absolute value function. He's got an awful lot going on. Let me draw my graph and then we can do some talking. Alright, so first thing that I want to do is I want to know that I'm going to go ahead and move him. Let's see if we can't get the basics. We're going to go up 2. We're going to go right 3. And this trumps everything. So I'm going to put that we're going to reflect over which axis. So ask yourself, is that negative contained in the function or in front of? So it is in front of, so we're reflecting over the x-axis. Okay, and I'm going to make sure you understand the reflection trumps it all. Alright, so let me do my parent. So the absolute value is the v. Now, I do my reflections I just do them without graphing them. So I say this point reflects to here. Now I go up to right 3. Okay? Reflecting over the x-axis when you're on the axis doesn't do anything. Up to right 3. I'm going to reflect. Then I go up to right 3. Okay. So we'll reflect beats the other one. Alright, I'm going to go ahead and do one more, and then we might be done. We might look at one example out of the book. Alright, let's try number 5. G of x is equal to the cubed root of negative x. Okay? So this time, good news, I don't have any vertical shifts or horizontal shifts. I do have a reflection. So my question for you is, where is reflection? It's inside the function, therefore we're going to reflect over the y-axis. Okay? So reflect over the y-axis. Alright, so let's get our cubed function up. Your cubed function is with your guy here. Okay, so he's kind of laying down. So he's, again, negative 1, 1, 0, 1, 1. Sometimes I struggle to draw this guy, so I'll see if I can't. There he is. Okay, so I'm going to reflect each point over the y-axis. So, reflecting over the y-axis, he goes here. This one stays. Reflecting over the y-axis, he goes over here. And I get this beautiful little graph. Like that. Okay? Alright, so the last one I'm going to show you is on page 206 in your textbook. Alright, so page 206 in your textbook. Alright, here we go. Number 48. So this is one of those weird ones where it's not something you could type into your graphing calculator. Okay? So we're going to go ahead and look at it, and it says that we want to do negative f x plus 1 minus 1. Alrighty? And I'm going to take a second and real quick sketch this on my graph paper. So I've got negative 4, negative 2, negative 2, 0, 0, 2, 2, 2, and 4, 0. And I want to do that g of x is equal to, I said I wanted to do number 48, negative f of x plus 1 minus 1. Alright? Let me unzoom now that we're not using the book anymore. Alrighty, so looking at my function, what am I doing? I should tell you guys this, but the book almost fell. You almost heard like a loud bang. I saved you from that. You're welcome. Alright, here we go. So I know this is going to tell me to go down 1. This tells me to go left 1. And this tells me to flip it over the x-axis, and that's going to happen first. Alright, here we go. So this point reflecting goes up here, down 1, left 1. He reflects and goes nowhere, down 1, left 1. This one reflects and he's 2 above, he goes 2 below, down 1 more, left 1. Reflecting, down 1, left 1. Reflecting goes nowhere, down 1, left 1. Alright, so I expect that you can do the ones not only that you could plug into your calculator, but these harder guys as well. Alrighty? So that's where we're going to wrap things up tonight. Have a great evening, and I will see you tomorrow.